SN7 is forms of
Okay,
equations of
so
lines,
first
and in
thing you'll
this
just want
lesson
to
we're
check
going
when
to
you're
talk about
factoring is
three different
your
forms that
corresponding
linear
factor.
equations can
So just
come
like a
in.
number
Just
basically
remember,
like
linear
whatever
equations are
word
something
variable
that
you
if
can
you were to
write, you
graph
can use
it would
all
end
the
up being
terms
a
that you
straight
have.
line on the graph. There would be
After
like
you
no
check the
bends
greatest common
or
factor,
curves.
if there's two
So in
terms, you want to
7.1,
see
we
if
talk
it's a
about
difference of
slope-intercept
squares.
form,
So basically like
which
one number is
slope-intercept
more minus
form,
another.
the
So like
formula
a
for it is
squared
y equals
minus b
mx plus
squared,
b. We're just going to go through
it
and talk
factors
about what
into
each
a plus
variable
b
means. So remember
times a
that
minus
like
b.
x and y,
And
those
then
represent our
for the
independent
three
and
terms,
dependent variables. So you can see there's an x
so
right
you have
here.
like
X
ax
is our
squared
independent variable. There's a y
plus
right here.
bx
Y
plus
is our
c.
dependent
You want to factor
variable.
using the
But we
x-method, so
really
you
just
set
kind of
up
want to
like the
talk
big
about
X,
what m and
and
what
then
b
on top
represent because
the
x and
big
y is
X,
something
a
that
times
we'll
c,
see pretty
and then on
frequently with
bottom is
all of our
b, and
equations.
then
They're just kind of our
the
input
same
and
with
our
the c up
output.
here,
So we'll
and
get
then
really
b, the
comfortable with
coefficient of
those,
x
but
down
m
here.
and b are something
And then
that's like
whatever
more
numbers
specific to
the
slope-intercept
numbers that you're
form.
looking for are numbers that like
So
multiply to a
m
times
is
c
our
but add up
slope.
to b. Whatever numbers you get
And
there, you
another, I
put them on
guess,
the left and the
phrase
right
that I
side,
want you to start
and then you write them
associating with
as like a
slope
fraction
is
over
rate
an
of
a value,
change.
so over whatever a is, depending on the problem. And then if you have four terms, you have to factor by
So
grouping.
slope
So I'm
or
gonna
rate of
go
change,
over an
which
example of like each
rate
one.
of change kind of describes what
So
it is
for
a little bit better.
like number
It's the
two,
rate at which the
the
line
first
is
thing you
going
always want to
up
check
or
for is
going
greatest
down,
common
how
factor.
quickly it's
So
increasing or
10x
how
y
quickly it's
minus 15x
decreasing.
squared y
And it's
squared.
really helpful to know that phrase once we
Between
start dealing with
10
problems that
and
give us
15,
context, like
they
word
both have a
problems.
common factor of 5, so that can be a part of my
And then
GCF.
for
And then
B,
for the
that is
variables, you
our
can only factor out
y-intercept.
like
So that's
the
where
like lowest
the
power that
graph
they all have in
crosses the
common.
y-axis.
So like this one has an
So if
x
I
to the
were to
first power,
draw
this
like a
one has
little
an x
sketch over here
squared.
off to the
So I can only factor
side
out an x to the first power.
and have a
And then for the
line
y's, this one has
on
a
my
y to the first power,
graph,
this one has a y squared, so I can only factor
it
out a
crosses
y
the
to the first power.
y-axis right here.
And
That
when you're
would be
factoring out
my
GCF,
b
it's just like
value,
doing
like the
opposite
number
distributing.
tick mark where
So
it
like what
crosses
goes
the
here is
y-axis.
going to
That's my b
be
value.
this
And
first
then the
term,
slope is kind of like
10xy,
the
divided
angle
by
of the graph,
5xy.
like how
So
steep
you
it's
could do
going up
like 10
or
divided by
down.
5, that's 2. X divided by
And
x,
then
that
on
cancels
to
out.
our
Y
first
divided by y
example.
also
So
cancels out.
starting right here,
And then what
writing linear
goes
equations when
as
given
the
2
next term would
points.
be
So
the
write the
second one,
equation of
like
the
negative
line that goes
15x
through the
squared y
points
squared divided by
negative 3,
5xy.
2,
So
and
negative
5, negative
15
6
divided
in
by
slope-intercept
5
form.
is negative
So
3.
I've
And then
written,
this
obviously,
like
all the
x
steps
squared
here in
divided
this
by
little
x.
table.
When
This is
you're
something I would like
dividing the
really keep
powers, you
handy when
subtract the
you
exponents.
are
So
first
it's like
doing
x
these problems and
squared
working through them. It's
minus
always
1
nice to have
basically.
like the
So that would
written
just
steps
become an
to
x.
follow.
And then for the y
So the
squared
first step is to
divided by
find the
y,
slope,
that would
which
just
is
become
m,
1.
and we do have a formula for slope, and I'm
And
actually going to show
then
you
you can
two different
always
ways that
check
you can approach
that
this.
you like
So I'm going to give you the
you
formula
can
right
always
here.
check
It's
that
m
you factored out GCF correctly by like
equals
distributing that
y1
in.
minus
Also,
y2
if you notice that like once you factor out GCF, if
over
there's still a common
x1
factor that you have like left over
minus
in the
x2.
parentheses, that just means that you didn't factor out the
Or
GCF,
another
like
way
the
that you
true
can think
GCF
of
initially, you
slope
just factored out
is,
like
or
a smaller
m,
one basically.
is the
But if
change
I
in
wanted to check
y
this, I could do 5xy times 2,
over
and that would
the
become
change in
10xy.
x, and that little
And then
like triangle that
5xy
I'm
times
putting in
negative
front of the x
3xy would
and
be negative
y.
15x
That's a
squared
symbol,
y squared.
it's like a
And then
Greek
that's like
symbol, I
actually
believe,
the formula,
but
so
it's
that's how you
delta,
write it
and it
correctly.
just means change. So it's just shorthand
And
for
then
change.
for number 4,
So first I'm
so
going to
4x
use the
squared
slope
minus
formula, the
21,
y1 and
there's
y2,
no like
to find the
greatest
slope,
common
and then I'm going
factor
to show
because you
you the
can't divide
alternative way
a1 by like
after.
2 or 4
So it doesn't matter
but it
which
is like a perfect
point you
square
make
minus being
your
a perfect
point
square,
1 and point
so it's a
2, you
difference
just
of
have to keep
squares.
it consistent.
The way
So I'm
it's
just
written
going to
right
leave it in the
now,
order that
the
it
4x
is,
squared
and
part,
then I'll
the
set up my
squared is
formula.
only
So
like
it's
a part,
m
or sorry, yeah, the
equals
squared is only a part of x.
y1,
So I would
which
just want to rewrite
is
this as like
this 2 right here.
2x in
Sorry,
parentheses
that's kind of
squared,
big.
because that means like
It's this
2
2 right
squared
here.
times x squared, so
So
it would
I'll
simplify
start with
back to
2
4x squared.
and
And
then
then in 1 is
minus
9 squared, so
y2,
minus
which
9 squared.
was
And then we
negative
want to
6.
compare it
So,
to
oops, we
like
have
this
to be
pattern up
careful with
here,
the
the a
negatives.
squared
So it's going to be
minus b squared
minus
factors into a plus b
negative
times
6,
a
and we'll
minus
use
b.
parentheses
So
because it's that double negative.
a is
So it
always
was
the first term,
y1,
b
2,
is always like the second
minus
term, regardless of
y2,
like which one is the
negative 6.
variable. A just comes first, b comes second.
And then
So
in
what
the
it's factoring,
denominator,
it'll
it
factor in
is
this like a
x1
plus 1
minus
times a minus
x2,
b.
so
So it'll
that
be
like
2x
x1 has
plus
to come
9
from the same point as y1 came from. I don't know why
times
that keeps
2x
doing that.
minus 9.
But so x1 is negative
And
3,
then you can check this one by like foiling. So if I did like
and then
2x times
minus
2x, it'd be 4x
x2, which
squared.
is 5. So minus
2x times
5.
negative 9, negative 18x.
So this
9
was
times 2x,
x1
positive
minus
18x.
x2.
now
And
I
then
have to
now we
equals
can go
negative
ahead and
9, negative
simplify
8,
now that
1.
we've set it up.
And then
So
the
if you have
negative
a
x,
double
negative
negative,
2
like we have
x's and
2
positive a squared,
minus
that
negative
cancels out.
6,
So we're left with
it
just
turns into a
4x
plus.
squared
So that 2 minus negative
minus
6 turns
81,
into a
and then
2
that was our
plus
original
6, so
problem,
that would
so
be
check mark.
8. And then I have in the denominator
And then I'm
negative
going to
3
skip
minus
down
5. It's like if we're
to
starting at
number
negative 3
8.
and then we go down 5,
So for
we
number
would
8,
end up at
3x
negative 8.
squared minus 20x minus 7 between
And then from
3,
there,
20,
I can
and
go
7.
ahead
There's no common
and I can
factor, and so
divide.
not all three terms have like an x attached to them, so there's
Sorry,
no greatest common
a
factor, but we
little
can pull
cold.
out everything
I
else, so
can
don't need to worry from
divide
there.
8
And
by
then this
negative 8.
has
So 8 divided
1,
by negative 8 is
2,
negative
3
1.
terms, so
And that's
if
my
it has
slope.
3 terms, we want to use the x
So the
method.
other way that you
So
can
you
do it
set
is, and I'll try to go
the
through
big
this way a little bit
X,
faster. So the change in y to the change in
and
x,
then a
I'm
times
just
c
going to
goes
kind of
on
do it
top,
off
b goes on
to the
bottom.
side up
So
here.
it's like
So I'm going to create my little
ax
fraction.
squared
So the change in
plus
y
bx plus
is if
c.
I go
So a
from
would be
2
3, b would be
to
negative
negative
20,
6,
c would
because
be
that's like
negative 7.
one y to the next
So
y.
a
So I'm
times
going from 2
c,
to negative 6 to go
3 times
from
negative
2
7,
down
negative
to negative 6.
21.
I would go
b
down
is
8.
negative 20.
And
So b
then
would 20
change
down
in
there.
x,
And
so
then
this
we're
was a
always
down
looking for
8.
numbers that multiply the top number but add up
So
to the
we'll come
bottom
back.
number.
And
So
then
if
the
you're
change in
multiplying
x
to
is I'm
like a
going
negative number like
from
negative 21, one
3
factor has to be
to
positive and
5,
one
or
factor
sorry,
has to be
negative
negative
3
to get like
to
a negative
positive
7.
5. So that would be
So
going like
multiplies to
up
negative
8
21
or
adds up to
positive 8.
20 would
So my
be,
change in x would be a positive 8. And then
positive
if
1
I
and
simplify
negative
those,
21.
negative
So
8
positive 1
divided by
times
8 is
negative
negative
21 is
1.
negative
So you get
21.
the
If we
same
add them
thing.
together, we get a
Like
negative
you're
20.
basically doing the same
And
thing,
then
it's just a
over,
little
we
bit
have to write
different
over our a
approach.
value.
So
So
you
this
can
problem is
decide like
3.
which way works
And
best for
then
you,
over
and feel free to like
3.
replay those two examples and decide which one you like more.
And then if you end up
But
with
either
a
way,
fraction,
RM
sorry, my thing like bugged out.
is negative 1.
If you end up with a fraction, you can,
Okay, so
you
on
should
to step
reduce it.
2.
So like
Substitute
for the
m
negative 21 over 3x, we probably
into
go with
y
rule
equals
3.
mx plus b. So
And then
we're
that
just going to
becomes
take that
negative
m, put it into the
7
formula. So
over 1.
Rm
And the
was
number in
negative
the
1. We're
denominator
going to
ends
take
up being
that,
like the
put it
coefficient
right
of your
there
variable.
where
So in this
m
case,
is
our
in the
variable is
formula.
x.
So it'd be
And you write
y
your factors from the
equals
bottom up. So it's going to be
negative
3x
1
plus 1.
x plus
So
b.
3x plus 1.
And since it was just a negative 1,
And
you
then
could
this
just
would be a
technically
x
put the
minus
negative sign
7.
if you
So
wanted
times
to,
x
but it does
minus
no
7.
harm to leave the 1 there also. And then moving on to step 3, choose a point to substitute in for x and y.
And then for
So
number
it does
9,
not matter which
if you look at
point you
number
pick,
9,
you just need to pick one
2x
of the
cubed
2 points
minus
from the original
3x squared
problem. So
minus
I'm going to
2x plus
pick
3.
negative
So this
3,
one, they
2
don't have
as
any
my
common
point.
factors that we can pull out because even though they have like a lot of repeat factors, there's none that are like in
And then
common for all
each
4.
point is organized
So
as
no
like x
GCF,
and
but it has 4
y.
terms,
So
so we're
we're
going to
going to
separate it
take these
into
point or
halves
at this
and
point
do
and
factor by
plug them
group
in
if there's 4
for x
terms.
and y. So negative 3 is going to go in where
Okay, so I'm going to
x
erase some of this
is,
just because it's in the way.
and then 2 is going to
But
go in where y
it's
is.
2x cubed minus 3x
So
squared
instead
and
of
then
y
minus
equals, it'll be
2x plus
2
3. So
equals,
for factor by
and
group, you
then
break the
negative
expression into
1, and
halves,
instead of
and then
x,
you
it'll
just
be
factor the
times
GCF
negative
out of each
3
half. So for the
plus b.
first half, it's 2x cubed minus 3x
And
squared.
then now that
So
we've done
between
that,
2 and
the
3,
only
the
unknown I
GCF is
have
just
left
1.
in my
But
equation
between
is
x cubed
b,
and
so
x
that leads
squared,
us
the
to
GCF is
step
x squared.
4,
So I'll factor
which
out x
is we can
squared.
solve the
When I
equation for
factor,
b.
divide that out of the 2x cubed, I'm left with 2x. And
So
then
in
when I
order to
factor,
solve, I'm
divide
going to
that
go
out of the
ahead
negative
and just
3x
multiply
squared, I'm
these
left with
two
negative
together.
3.
I'm going to do that step down here just so it kind
And
of
then I
falls
do
in
that
line
same
with
thing with
step
the
4.
second half of the
So
expression.
2
My goal is to
equals
get the same thing
negative
in
1 times
parentheses.
negative 3
So
is
I have a
positive
negative
3 plus
2x and a
b.
plus 3. I'm going to
And
factor
then
out
my
a
goal is
negative
to
1
get
as
b
my
by
GCF,
itself.
and then that's
So
going to
I'm
just
going to
like flip the
subtract
signs. So
over
negative
that
2x
3
divided
to
by
cancel
negative
it
1
out.
is 2x.
And
3
then
divided
2
by
minus 3 is
negative 1
negative
becomes minus
1
3.
equals
And
b.
then we
So
end up
now I
with the
know what
same
b
thing in
is.
parentheses here, which you have to have that if you
And I
don't
can
just
just
want to
take
backtrack and
that
like try to find
b
a mistake.
and the m that I already
But
know.
basically, no.
So I
This
know
is one term,
b is negative 1, m is
and then
negative
this is
1.
another
Oh, what are
term.
the odds? I don't know.
And then,
But I can just take
because each
those
of those
and plug
terms
them
has
both
like a common
into my
factor of
formula, y
2x
equals
minus 3,
mx plus b.
I can factor that 2x
So
minus 3
altogether,
out.
it'd be y
And then
equals,
what I'm
m
left
was
over with
negative
once I
1, so it'd
pulled
be
that 2x
negative
minus 3 out
1
of both
x,
terms,
and
sorry, I
then
switched terms
plus
too,
b would be,
is
instead of plus
like a
b, I'd write
new
it as
noble
minus
factor.
1.
So
And then just
after I
remember
factored it out of
that
the
you don't have to
first one,
write the 1 in
I'm
front
left
of
with an
the
x
x,
squared.
so you could just write it as y
And
equals
then after I factored out of the second
negative
term, I'm left
x
with a minus
minus
1.
1.
So x squared minus 1, that becomes like my second half of my second factor basically. So one more time, like whatever is my common factor right here, I can factor that out of each That goes up
Okay,
here.
moving
And
down
then after I
to
factor
our
that
word
out,
problem
each one,
example.
I'm left
So
with x
writing linear
squared
equations
minus
from real
1. So
world
that becomes its like
situations.
own
So
separate factor. And then you just always want to
starting
make
from
sure
right
before you
here,
factor any
Samantha
further.
was
So
curious about
this,
how
like x
fast she
squared minus
reads.
1
She
is
wrote down
whatever
how
the
long it took
squares,
her to
right?
read
Because
up
it's
to a
x
specific
squared
page number in a book.
minus 1
The
squared.
following table
So
shows the
this is
page
like my
number she
a,
read
and this is
to
my
and
b,
the
a
number
squared
of
minus b
minutes that
squared,
she read.
like my directed
So
squares
this
pattern. So that part
looks
can be
like a
factored
different
further.
problem, but
The
we
2x
can
minus
actually
3 is
treat
going
it
to stay out
almost
in
the
front.
same exact
And
way.
then since
I
it's
know that
directed
we're given
squares,
this
like
table
if we write the
instead of
pattern,
like 2
a squared
points like
minus
we
b
were with
squared,
this
that
last
factors into a
example.
plus b
But
times
really, a table is just a
a
different way
minus
of
b.
organizing points.
If
So we
my
just need to
a
pick
is just x
two
and my b
like
is just 1,
pairs
that's going to
from
factor
this
into x
table,
plus 1
and we can even just rewrite them as points. So we can
times
use
x minus
5,
1.
8,
So
and then
2x minus
10,
3 times
11.
x plus 1 times
And if
x
you
minus
want, you
1.
can just write them as like 5, 8,
And then the last two, which I
10,
won't like finish, just so
11.
it's shorter for you to watch. For
And then we
11,
want to write
for
the equation,
2x
so we're doing
squared
the same
minus
thing as we did the
32, I
last
just want to
example. I'm
check
just
for
going to
DCF
follow those
first. So
same
like
exact steps.
between
So for
2x squared
step
and negative
1,
32, I can factor out a 2. And then that leaves me with x
we got to
squared
find
minus
m.
16.
So you can
And
use the
then you
slope
always want to check CF
formula,
to be factored
or you can
further
find the
because
change
x
in
squared
y. I'm
minus
going to do it a
16
little bit
can't be
differently
because
this
it's
way,
like
just
a
so you guys have an
difference of
example of
squares, or
each
it's like two
one.
perfect squares being
So m
subtracted.
equals the
So we
change in
factored
y
further
over
like
the change in x.
for the
So
way we
for
factored before.
y, I'm going from
And then for
8
12, 6x
to
squared
11.
minus 21x
So to
plus
go from
9.
8 to
I
11, I
can
have to
factor,
go
there's a
up
GCF, like
3.
all three of these can be
And
divided by
then
3. So
for
I can
my
factor out a
change in
3.
x, I'm going from
It would give me
5
2x
to
squared
10,
and then
so I'd have
minus
to go up
7x plus 5.
5. So my
And then
change
from
in
there, I can take
y
this new
is
like
3.
three-term
It went
trinomial
up
thing,
3.
and then
My
use the
change
x
in
method to
x
factor that all the way.
is 5. I went up 5. So 3 over 5 is my slope. And it's actually better just to leave it as a fraction. So we're going to leave it as 3/5 as opposed to like changing it to a decimal. Okay. And then just really quick, if you prefer the slope formula, I'm just going to do it off to the side or down here so we kind of get practice with both and you can decide which one you like more. So I'm going to say that this is my, in this case, I'm going to say this is my point 1 and this is my point 2. So this will be like my x1, y1. This is my x2, y2, just so I can like subtract from a bigger number. So the slope formula, y1 minus y2, x1 minus x2. And then from there, y1 is 11 minus y2 is 8 over x1 is 10, x2 is 5. So it'd be 11 minus 8, which is 3, 10 minus 5, which is 5. So just the point of that is like you get it the same thing either way, so you can decide which one you like better. So either way, our slope m is 3/5. And then step 2 is to take our slope and plug it into y equals mx plus b for m. So I'm going to take that 3/5 and I'm going to swap the m out for it. So it would become y equals 3/5 x plus b. And then my next step is to take one of my x and y values and plug them into the equation. So I'm just going to rewrite where I finished for step 2. So we're starting with y equals 3/5 x plus b. And then I need to pick just one of my points. It could be any one of them. It could be something from the table. It could be one of the ones I used up here. It's totally up to you. But I'm going to use 5/8 as my point. And like I said, you could get the same answer you're picking a different point. So I'm going to take, this is my x, this is my y. I'm going to take the 5, put that in for x. I'm going to take the 8, put that in for y. So then it'll be 8 equals 3/5 and then times 5 plus b. And then step 4 is to just solve for b. So I'm kind of running out of room on this page. So I'm going to pop up step 4 over here. I'm just going to rewrite my equation that I ended with for 3. And I don't expect you guys to necessarily like write all these steps. I would just like for your guys' like for your sake, when you're watching back, you can see the difference between the steps so that you can match them up with the written steps up here, is more of why I'm separating them so much. Okay, so the goal now is to solve for b. So over here I have like 3/5 times 5, and so I can think of this as 5 over 1 if I want to, but I can go ahead and just like cross cancel the 5's, because if I divide them both by 5, they go away. So then I'm just left with 8 equals 3, and then plus b, and my ultimate goal is to get b by itself, so I'm going to subtract over the 3, and then 8 minus 3 is 5 equals b. So we have b, we already had m, and then now I just need to go ahead and take those both and put them into my formula. So for step 5, the formula is y equals mx plus b. I'm going to take that 3/5 that I had for m, put that in there, and then I'm going to take the 5 that I just caught for b, put that in there. So it's y equals 3/5 x and then plus 5. 7.2 is point slope form, which the name kind of tells you exactly what you need to be able to use this form. You need a point and the slope. So point slope form is y minus y1 equals m times x minus x1. And then m has the same meaning here, it's the slope. And then x1 and y1 are a given point, or they come from a given point. And then the x and the y that don't have the one next to it, those just stay a part of your equation. So you wouldn't substitute anything in there for those usually, at least when you're writing the equation. So example 1, Bailey is baking some cookies for a bake sale. She knows that for each batch of cookies that she makes, she needs 1.5 cups of flour. So that's an important piece. For 6 batches of cookies, she uses 17 cups of flour. So it looks like that might be some more important information. So remember, we're not really only expected to like read through word problems once, so just one more time to get a better idea of what it's asking. Bailey is baking some cookies for a bake sale. She knows that for each batch of cookies she makes, she needs 1.5 cups of flour, so she uses 1.5 cups of flour per batch. And then for 6 batches of cookies, she uses 17 cups of flour. The next part says write an equation in point slope form, which is that formula up above that represents the amount of flour used, then convert the equation to slope intercept form. So this question has 2 parts. There's part 1 where we're writing the equation, and then step 2 we need to convert to slope intercept form, which that is like the y equals mx plus b from 7.1. So before we can start, I think we should define our variables. So we know that x is our independent variable, y is our dependent, but we want to talk about what they mean in the context of this problem. So how much flour she uses depends on how many batches of cookies that she wants to make. So we're going to say that x is the number of batches of cookies, and then y is the cups of flour. And then when we're trying to find our slope, remember that I said that another like phrase for slope is the rate of change. So kind of like the rate at which she's like using flour. And it says right here that she needs 1.5 cups of flour, sorry, for each batch. So that 1.5 cups, that's going to be our slope. That's the rate of change. That's the rate that she's like using up flour per batch. So we can say that m is 1.5. And then the other thing that we need for point slope form is a point. So we said that x represents the number of batches, y represents the cups of flour. So it says here that for 6 batches of cookies, she uses 17 cups of flour. So that's 6 batches of cookie. That can be our X for our point. And then the 17 cups of flour, that can be the Y for our point. So we can use the point 6, 17. So 6 batches, 17 cups of flour. And then now that's all we need to plug into our equation and write the equation of the line, basically. So I'm going to rewrite the formula down here. So it's y minus y1 equals m times x minus x1. And then we know m, that's 1.5. That'll go here. And then this 6 will be our x1. So that 6 will go right here. And then the 17 will be our y1. So that 17 will go right here. So it'll be y minus 17 equals m, so 1.5 times x minus x1, so x minus 6. So that is like the answer for the first part. This is our step 1 answer because it says just write the equation in point slope form, and this is in point slope form. And then for step 2, or the second part of the problem, it says then convert the equation to slope-intercept form. So I'm just going to rewrite that equation that we just wrote over here so I have a little bit more room to work. So y minus 17 equals 1.5 times x minus 6. And if you look at the formula for slope-intercept form, that's our y equals mx plus b. The big thing here is that y is by itself. So let's try to focus on getting y by itself. And the other side of the equation is simplified. So I think it's a little bit easier if we simplify this first, meaning that we distribute. So it'll be y minus 17 equals, and I'll go ahead and distribute. So 1.5 times x is 1.5x. And then 1.5 times negative 6 should be 9. So 1.5 times negative 6 turns into a negative 9. And then my goal is to get the y by itself eventually, so I need to cancel out that minus 17, so I'm going to add 17 to both sides. And then I have y equals the negative 17 plus 17 cancels out. I bring down my 1.5x, and then negative 9 plus 17 would be a positive 8. So I'd end up with y equals 1.5x plus 8, and then now that's in my like y equals mx plus b form. So that's my final answer for the second part of the question. The final form is in standard form, which is in 7.3, and the formula for standard form is ax plus by equals c. And in point slope form and in slope intercept form, they had variables that represented something specific, like how m was for slope. Standard form doesn't really have that, it just kind of varies by the problem. So example 1, Max is having some friends over, so he decides to buy some candy. Chewy bars cost 75 cents each. Caramel bars cost $1.25 each, and if Max spends $11.25 on candy, write a linear equation in standard form that models the situation. So here, we don't necessarily have like our independent and dependent variable. X and Y are just both going to represent their own candy bar. So it doesn't matter which one we make which. I'm going to say X is a Chewy bar, or like the number of Chewy bars that he buys. And then Y will represent the number of caramel bars. And then now that we've defined our variables, we can set up our equation. So since Chewy bars cost 75 cents each, if we take 75 cents and we multiply it by the number of Chewy bars that we buy, that's going to give us like how much money we spend on Chewy bars. So our setup would start off with 0.75 times x, since x represented Chewy bars. And then for the caramel bars, they cost $1.25 each. So if we take $1.25 and multiply it by Y, which represents the number of caramel bars that we're buying, we'll get how much money we spent on caramel bars. So it'll be plus $1.25 times the amount of caramel bars that we buy, so times Y. And then if we add those two together, we'll get the total that Max spent, which is at $11.25. So just to kind of like recap that a little bit, this 0.75x is 75 cents per caramel bar. So 75 cents times the number of, or sorry, chewy bars. 75 cents times the number of chewy bars that were bought. Over here, $1.25 that's $1.25 times the amount of caramel bars that were purchased. And if we take those two together, we get our total amount spent, which is $11.25. So our equation that represents this situation is 0.75x plus 1.25y equals 11.25. And then over here on the right, it says now convert the equation from example 1 into slope-intercept form, which that's y equals mx plus b. So I'm just going to take my equation and copy it up to the top there. And then we'll start fresh and we'll convert it to slope-intercept form. So I'd rewrite it just so you can kind of see the separation. But remember that slope-intercept form is y equals mx plus b. So our ultimate goal is going to be to get y by itself. So there's not really any simplifying we can do with this equation. We just have to start moving things away from the y. So like right now I have this 0.75x that's being added to the y, and I have this 1.25 that's being multiplied by it. So remember, we usually undo addition or subtraction first when we're trying to move things away from what we're solving for. So I'm going to cancel out that 0.75x by subtracting 0.75x from both sides. So 0.75x minus 0.75x cancels out, and then I bring down my 1.25y. And then notice with slope-intercept form, the term that has x goes first, and then the number without x goes second. So I'm actually going to write this negative 0.75x first. So minus 0.75x, and then I'll put this is a positive 11.25, so I'll put plus 11.25 next. And then now my goal is to still just get this like y by itself. So I have a 1.25 that is being multiplied by it. So to cancel it out, I'm going to divide both sides by 1.25. And I have to divide everything by 1.25, every single term. So this gets divided by 1.25 and this gets divided by 1.25 as well. So these cancel out. So I'm just left with y, which is good. I bring down my equal sign. And then next I'm just going to use a calculator and I'm going to divide negative 0.75 by 1.25. So negative 0.75 divided by 1.25 is negative 0.6. So it'll be a negative 0.6x. And then next I'm going to do 11.25 divided by 1.25. So 11.25 divided by 1.25 is 9, so plus 9. So y equals negative 0.6x plus 9. And then the last little example I want to add in is just how to write vertical lines and horizontal lines. So vertical lines are lines that go up and down. I'm just going to make a random example on here. So let's say I have this line. So a few points that are along that line could be, say this is the point 5, 3, nope, sorry, that was backwards, 3, 5. I think we've all done it. This is the point, let's say 3, 1. And then like this is 3, negative 4. So the one thing that's consistent about everything on every point that's on that line is they all have an x value of 3. And anywhere along that line, because we're not going left or right, we're just going up or down, so that x coordinate is going to stay the same. it's always going to be crossing through at x equals 3 or 3 on the x-axis. So we would write that vertical line as x equals 3. So every vertical line is always going to be x equals, and then whatever x number it crosses through on the x-axis. And then for horizontal lines, let's say, draw this line, and then pick a few points on that line. So this is 4, 5. This is negative 2, 5. Over here, negative 8, 5. So notice on this line, the point that's consistent on, or the coordinate that is consistent for all the points is has a y coordinate of 5. And so every horizontal line you're going to write as y equals, and it's just going to be equal to whatever value it crosses on the y-axis. So in this case, it's y equals 5. And technically, horizontal lines you can write in y equals mx plus b form. It's just because it's flat, the slope is 0. So it'd be like y equals 0x plus 5. And 5 is our y-intercept. But we're going to get a lot more into that in the future. But for now, just kind of know that vertical lines are x equals the number, horizontal lines are y equals the number.